Okay, so I'm going to do number 8 and number 9. So to do number 8, let's zoom in here. We are going to separate the integral of a sum into the sum of the integrals. So we are going to integrate 4x plus dx plus the integral of secant squared x dx, and both of those are evaluated from 0 to pi over 4. The integral of 4x is 4x squared over 2. The integral of secant squared x is tan of x. So to clean up, we're looking at 2x plus tan of x from the bounds 0 to pi over 4. So we have taken the integral of this function, which is right here, and then we are going to evaluate on the bounds from 0 to pi over 4. And according to the fundamental theorem of calculus, we do f of pi over 4 minus f of 0. So 2 times pi over 4 plus tan of pi over 4. Okay, minus 2 times 0 plus tan of 0, tangent of 0. And then you're going to end up at that point with pi squared over 8 plus 1, because this is 0, and tangent of 0 is 0. And you're going to end up with, oh, it's 2x squared. Sorry, I made a mistake there. Sorry. So 2 pi over 4 squared. So it's going to be pi squared. Once you simplify this out, tan of pi over 4 is 1. So you end up with pi squared over 8 plus 1 as the area under the curve of this function from 0 to pi over 4. So this is the area under the curve of this function starting at 0 and ending at pi over 4. If we take a look at number 9, we're looking at the absolute value of 4 minus 2x. Now, we need to think about splitting this into two integrals. First, let's think about the graph of the absolute value of 4 minus 2x. This will help you see why we need to split it into two integrals. Because first of all, if we integrate 4 minus 2x, what function gave us the derivative of absolute value of 4 minus 2x? We don't know. Okay, so let's take a look at the graph of 4 minus 2x. When we take the area under the curve from 0 to 2, which is the vertex of 4 minus 2x, we're taking the area under the curve of the line 4 minus 2x. See, we've got a y-intercept of 4 and a slope of negative 2. But when we take the area under the curve from 2, which is the vertex, to 5, we are no longer taking the area under the curve of this line. We're now taking the area under the curve of the line 2x minus 4. And how do we know that it's that line? Well, because it's not the reciprocal, it's the reflection of this line. We're flipping 4 minus 2x over the y-axis, so to say. And we're flipping it, you know, through the symmetry here, through the vertex, which causes everything to reflect, okay? You can also do test points, you know, test some points in. If you plug in an x value of 3, 2 times 3 minus 4, you're going to get 6 minus 4, which is 2, right? So when x equals 3, y equals 2. So let's plug that in here. 4 minus 2 times 3, that's 4 minus 6, which is negative 2, which is 2. So this works, right? This works. So this is the line 2x minus 4. This is the line 4 minus 2x. So how do we split that into two integrals? Well, we're taking the integral, or the area under the curve, from 0 to 2 under the line 4 minus 2x dx, plus, let's put that in black, the integral from 2 to 5 under the line of 2x minus 4 dx. Okay. And then you will go ahead and evaluate those integrals separately. So you're going to integrate and then do f of 2 minus f of 0. And then you're going to integrate do f of 5 minus f of 2, and then add those two answers together. Try that and see if you get the final answer of 13. Keep in mind we talked about how to use our calculator. If you have a TI Inspire, that's probably what we went over in class, and I'm making this video before class, so we'll see. If you have the TI Inspire, it's easy. It's a button you press and you just put in your bounds and your function and integrate it. If you have an 84, that makes you do the plugging in, which I think there's only a couple of you. It's Math 9, and this is the programming. You have to do y1, put the function in y1 and do y1 x, the lower limit number and the upper limit number. So if you were, let's say, integrating this one, you'd put 2 plus sine x inside y1, like if you were going to graph it, and then you call this and put 0 as your lower limit and pi as your upper limit. A lot easier if you have a TI Inspire or a newer 84 plus, and that's probably the one we did in class.